Today we're going to learn our next lesson on rational exponents, which are just fraction exponents. Whenever we have a fraction in our exponent, the denominator of this exponent is going to be our root. So square root, cube root, or any root. So for example, if we look at number 1, this 2, which is the denominator of our fraction, is really going to be our square root. So we can rewrite this as the square root of 100 to the first power. Square root of 100 we know is 10, and so that's our final answer. For number 2, so using our exponent rules, we know that these two we're going to multiply. So this is really the same thing as 16 to the power of 3/2 times 1/2. When we multiply fractions, we multiply straight across, so this becomes 16 to the 3/4. And now this 4 is our root, so if our 4 is our root, we can rewrite this as the 4th root of 16 to the 3rd power. Now to figure out what our 4th root of 16 is, we're going to use our chart to look at what the 4th root of 16 is. So this is so if you look at your chart, you know that 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16. So what to the 4th power gives me 16? The 4th root of 16 is just 2. So we can rewrite 4th root of 16 is 2, and then we have 2 to the 3rd, which is just equal to 8, and that's my final answer. So whenever we're doing roots, we're just looking for what to the whatever root that power is equals the number that's inside the square root. So for example, let's look at number 3 now. For number 3, remember that this negative is outside of the number, so it's going to stay outside there until the very end. This 3 is our fraction, the denominator, so this is going to be our root. This is the cube root of 27, and then our 2 is still the power of 2. So again, we're looking for what to the 3rd power is going to give me 27. You might already be able to guess. So if you look at your chart again, we know that 3 to the 3rd power gives you 27. So we can rewrite this whole thing as 3. We still have the squared. And we know that 3 squared is equal to 9. And so the number 3 is just negative 9. The difference between number 3 and number 4 now, number 4 has a negative inside the parentheses. So that means this entire thing is going to be being raised to the 2/3 power. Again, the denominator is 3 is our root. So cube root. This time the negative 27 is inside, and we still have it squared. So what to the 3rd power gives me negative 27. So this time instead of it being 3, it's going to be negative 3. But negative 3 is what is being cubed, because this is all inside the parentheses. Alright, so what's negative 3 or squared? What's negative 3 squared? It's positive 9. So this one's positive instead of negative, since our negative is on the inside. Okay, let's look at number 5 now. For number 5, unlike 3 and 4, this is now my negative exponent. If it's a negative exponent, what am I going to do? I'm going to flip it. So instead of being 27, this is going to be 1 over 27 to the 2/3. After that, all my steps are the same. I'm still changing the denominator to my root. So this is 1 over cube root of 27 squared. Cube root of 27, what cube gives me 27? It's still 3. So 1 over 3 squared, which is equal to 1 over 9. Number 6 is very similar, but this time I have a negative 27 to the negative 2/3. Again, the negative exponent is what's going to flip this to the denominator. So now it's the negative 27 to the positive 2/3, because I got rid of the negative since I moved it to the bottom. Again, the 3 is my root, and this is negative 27 is inside of that, squared, since it's inside the parentheses. Cube root of negative 27, what cube gives you negative 27? It's going to be negative 3. Keeps the negative because of the odd. And now we're going to be squaring negative 3, which is going to give me 1 over, again, positive 9. So these two are actually both positive, since when we square it, it becomes positive. Okay, let's move on now to some expressions with variables. So if we look at number 7, we're trying to simplify this as much as possible so that we have all positive and rational exponents. So the first thing we're going to do here is we're going to rewrite this. So this 6 is my root. So this time I'm going backwards from what I did before. So right now I have an 8, a to the negative 1, b squared. And it's to the second power. So now this 6, which is my root, I can rewrite as over 6 in my exponent. Right? So again, my root is in the denominator of my exponent. And now I can simplify this. 2 over 6 is the same thing as 1/3. And before I distribute this, let's rewrite this part. So this a to the negative 1 really is going to be at the bottom, because I don't want any negative exponents, just positive ones. And now I'm going to distribute. So I want 8 to be raised to the 1/3, b squared to be raised to the 1/3, and a to be raised to the 1/3. So 8 to the 1/3, this 3 is at the bottom. We're trying to find the cube root of 8. So what to the third power gives me 8? Let's look at our chart. That's really 2. For b, we're going to multiply 2 and 1/3 together, which just gives me 2/3. And then I have a to the 1/3 at the bottom. Now I've simplified as much as possible. I can't combine any other bases because these two are different. And they're all positive exponents, and they're all rational. So I'm done with number 7. For number 8 now, again, let's start off by rewriting this. So this is x to the square root is like there's a 2 right there. So again, this is going to be 1/2 now, because the 2 is at the bottom. Cube root is going to be 1/3. 6th root is going to be 1/6. So all the roots go in the denominator of your fraction exponent. Now when we multiply these like this, so to the same base, really what we're doing is adding our exponents. So we're adding 1/2 plus 1/3 plus 1/6. For you to add these fractions, you need them to have the same common denominator. So if we look at 2, 3, and 6, your least common denominator here is 6. So to get there, we need to multiply by what's missing. So for the 1/2, to make the denominator equal to 6, we're going to multiply by 3/3. For the 1/3, we're going to multiply by 2/2. The 1/6 doesn't need to change. So we have now 3/6 plus 2/6, excuse me, plus 1/6. So again, 3/3 times 1/2 is 3/6. 2/2 times 1/3 gives me 2/6, and then I'm adding to 1/6. So now we're adding the numerators. 3 plus 2 plus 1 gives me 6 over, keep my denominator, which is 6. 6 divided by 6 is just equal to 1. So really, this entire thing simplifies to just x by itself.